Hello everyone, myself Ruchita from Sri Venkateshwara College of Engineering, fourth sem CSE. Today I am here to explain about registers and the types and current program status registers. Let's go. So what is register? Registers are the high-speed memory storing units. It is an element of a computer processor. Registers can carry any type of information including a bit, sequence or a single data. A register should be a 32-bit in length for a 32-bit instruction computer. The registers are identified with the letter R prefixed to the register, the number. For example, register 4 is given the label R4. There are up to 18 active registers, 16 data register and 2 processor status register. So, in this figure, we know about the 16 data register and the 2 processor register. So, R0 to R15 are the data register and CPSR and SPSR are the program status registers. The register is available to the programmer as R0 to R15. The ARM processor has 3 registers assigned to a particular task or specific function. They are R13, R14 and R15. R13 is called as a stack pointer, R14 as link register, and R15 as program counter. The R13, R14 and R15. These processors are frequently given different labels to differentiate them from other registers. The register R13 is traditionally used as a stack pointer (SP) and stores the head of the stack in the current processor mode. The register R14 is called the ring register, and it is where the core puts the return address whenever it calls a subroutine. The register R15 is the program counter. It contains the address of the instruction that is to be fetched by the processor. Register R13 and R14 can also be used as a general purpose register, which can be particularly useful since these registers are banned during a processor mode. However, it is dangerous to use R13 as a general register when the processor is running any form of operating system because the operating system often assumes that R13 always points to a valid stack frame. In the ARM state, the register R0 to R13 are orthogonal. Any instruction that you can apply to R0, you can equally apply to any other registers. However, they are instructions that treat R14 and R15 in a special way. In addition to the 16 data register, there are two program status registers that are CPSR, so-called Current Program Status Register, and SPSR, Saved Program Status Register. The register file contains all the registers available to the programmer. So let's now know about the types of register. So the first type of register are user accessible register. It is most common division of the user accessible register into data register and address register. So what's data register? They are used to hold numeric values such as integer and floating point values. Address register holds the address and are used by the instructions to directly access the memory. What is conditional register? They hold truth values, often used to determine whether some instruction should be executed or not. General purpose register. They can be stored both data and address, that is, they are the combination of data register and address register. Floating point register. They store the floating point number in many architectures. Constant register. They hold read-only values such as 0, 1 or 5. Special purpose registers hold program status. They usually include the program counter, stack pointer, and status register. In embedded microprocessor, they can also correspond to special hardware elements. Control and status register. They are used to store information about the instruction received from the machines. Now let's learn about current program status register. The ARM core uses the CPSR to monitor and control internal operation. The CPSR is dedicated 32-bit register and it resides in a register field. The CPSR is divided into 4 fields. Each, each bit is 8-bit wide. The 4 fields are flag, status, extension and control. This is the figure of the CPSR. In this figure, we know the status bit and the extension bit. They are reserved for the future use. The control field contains interrupt mask, thumb state and processor modes. And the flag bit contains conditional flags that are N, Z, C and V. N stands for negative, Z for 0, C for carryover and V for overflow. Let's know what are the jobs. The negative N bit is set when the result is negative in 2's complement arithmetic. The 0 bit is set when every bit of the result is 0. The carry bit is set when there is a carry out of the operation. The overflow bit is set when the arithmetic operation results in an overflow. In the interrupt bit, the I disable interrupt request when it is set. F disable fast interrupt request when it is set. Let's know about the processor modes. The processor modes determine which registers are active and the access rights to the CPSR register itself. Each processor mode is either privileged or non-privileged. The privileged mode allows full read and write access to the CPSR. A non-privileged mode only allows read access to the control field in the CPSR, but still allows read and write access to the control flag, conditional flag. There are 7 processor modes in total. 6 belongs to the privileged mode and 1 to the non-privileged mode. The 6 privileged modes are abort, fast interrupt request, supervisor, system, and undefined. Let's know the functions. The processor enters abort when there is a failed attempt to the access memory. Fast interrupt request and the interrupt request correspond to the two interrupt levels available on the ARM processor. The supervisor mode is the mode that the processor is in after reset and is generally the mode that an operating system kernel operates in. The system mode is a special version of a user mode that allows full read and write access to the CPSR. Undefined mode is used when the processor encounters an instruction that is undefined or not supported by the implementation. The one non-privileged mode is the user mode. It is used for the programmers and application. So this is what we learned about CPSR and registers. Thank you.